Hi, and welcome back to Algebra 1. Our goal for today is our final review of our sort of introductory stuff to linear relationships. So at this point, I should understand that an ordered pair, which gives me a description of a point's location in a coordinate plane, is always in this format of x coordinate comma y coordinate. It's important that I understand it has to be in that particular order, which is how far did I move right or left from the origin goes first. And my second number then tells me how far did I go up or down. If I can't write good ordered pairs, I'm going to struggle throughout the rest of this year in algebra. So make sure that you're really thinking about what is that order of that description of any point that's in a coordinate plane. From there, we talked about what are called the x and y intercepts of linear relationships, or of a line or an equation that forms a line in graph format. So an x-intercept is that point on our line that crosses the x-axis. And so in this particular case, what is this x number when our y is 0, right? That's what we're looking for when we have a x-intercept. Solve for the x when y is nothing, right? We didn't go up or down. And then for our y-intercept, it's our point or location where our line crosses our y-axis or our vertical axis. Or down here, what our x is 0, what's our y, right, when our x is nothing, right? That's what we're really trying to solve for when we have a y-intercept. So from picture or graph format, it's fairly simple, but when I have to take these values and substitute them in and solve, right, or take this value of x and substitute in and solve, and we really have to be thoughtful in the end of when we write that ordered pair. Are we solving for x because it's an x-intercept, which means I'll have a number comma 0? Or am I solving for this y because I'm solving for a y-intercept and I'll have 0 comma something, right? So my y-intercept, this number, the y one, is the one we're solving for. And for this x-intercept, this first number, the x number, is the one we're solving for, so just be careful. All right, over the last lesson, we introduced our last introduction thing with a line or a linear relationship, which is called rate of change or slope of our line. It describes the steepness of our line, or what is that ratio if we started here at the origin, since both these lines go through the origin, and we go up and then we go over to get to our line. What's that ratio of our change in our y's, which is an up-down amount, compared to our change in our x's, which is a left-right amount, right? So you can see that red line. It's a pretty far distance up compared to how far over. Compared to this guy where we just barely go up and over, right? So this change in y to change in x ratio is going to be a smaller fraction, where the red line is going to have a larger fraction amount. Right? The steeper the line, the higher in value our rate of change or slope. Now, when we're done calculating, we have 4 different possibilities here. What's called positive slope, what's called negative slope, what's called 0 slope, and what's called undefined. So let's go real quick on our hike again. If we're heading up the mountain, right? So I know this first one, this first line here, I'm calling a mountain, right? But it may be, call it a molehill, right? So we're still traveling in that up the molehill direction. Same thing here, we're going up the hill, right? Those are examples of lines that would end up with positive slope. If we're going to hike the line and we end up going down, right? If we're heading down that line, then those are examples of lines that have negative slope. Now, our horizontal, perfectly not diagonal lines are sort of our special cases here. So right now, this horizontal line, it's like we're on the top of the mountain. That's when we end up with 0 on the top of our fraction. Let's say there's like a 7 here, right? A 0 on top and a number below. In that case, we're going to simplify to 0 over 1. When we're on the top of the mountain like this, our slope is when we have 0 on top, and it simplifies to 0 over 1. Now, slightly different from when we have a completely up and down, right? Our line right here is completely vertical, completely up and down, which is different, right? That's when we would fall off the edge of the cliff or off the edge of the mountain. We'd go tumbling, splat, and our body would end up being undefined, right? So that's our undefined slope. And in fraction format, we'd have, I'll use my same numbers, of 7 on the top and 0, let's say, on the bottom. When 0's on the bottom, that's when we end up down here on the bottom of the mountain, which means our final simplified thing would be the word undefined, because we don't have a number to represent that. You can't have 0 in the denominator of a fraction, so be careful. It's a special case. Even when we're calculating, we have to use that word undefined, so be careful. So yesterday we looked at, what if I'm given 2 points, right? I'm given these 2 points. I can call one of them point number 1 and one of them point number 2. I can take that, substitute it into my slope formula of what's the change in our y's from our ordered pairs over what's the change in our x's from our ordered pairs, and then simplify, no decimals, no mixed numbers here, to get the final ratio of what's our change in y over change in x. So today things are going to get a little bit trickier because I'm not just going to be given those 2 points. I have to pull them from the picture or from a table that supports a line if we were to graph it, or in picture form, it's already the graph of the line. So again, those 4 scenarios are still our 4 scenarios: positive, negative, 0, and undefined. So let's look at one. All right, so we have a picture here of a line. And what I did was I went through that line and I found any place on that line where it seemed easy to pick out an ordered pair for, because it landed perfectly on the sort of like grid marks of our coordinate plane. So I've pre-placed 1, 2, 3, 4, 5, 6, 7. All right, now that line has infinite solutions, meaning infinite points on it. Those 7 are just the ones we can see in our picture here that are in perfect locations and are the easiest to work with. We need 2, that's it. So I've given way extra than what we need here. We need to pull out any 2 places on our line, and then we call 1.1 and 1.2. We can use that to help us get our slope or rate of change of the line. Now, I don't care which 2 you pick. So let's say we use this guy here. The first thing I want to do is write out that ordered pair that would go along with it, right? We need the points. So if you tend to mess up on using the ones that are on the axes, right, don't use that one. Go to like this guy over here or this one here or something, right? You can use any 2. You're going to have extras here. So when it's on your y-axis, that means we have a y number and our x is 0. So 0, comma, right? This is going to be our y-intercept. In this case, it's up 2. So 0, comma 2, which is our y-intercept. We can use that. It's a point on our line. All right, I'm not going to use this guy. Let's go down here to this one, all right, just to show we can use any points we want. So 1, 2, 3, 4 to the right would mean we have a positive 4x, right, 4, comma. And then 1, 2, 3, 4 down means we have a negative 4. Now, if I mess up here and I say like 4, comma 4 instead of 4, comma negative 4, or I put 2, comma 0 instead of 0, comma 2, then my calculations are going to be off. So I really have to look at these ordered pairs that I write up for x1 and y1 and x2 and y2 and really double check and make sure they're good. All right, from here, we're going to substitute in. We called our y2 negative 4 and our y1 2 over 4 minus 0. All right, let's subtract, and then we'll think about if we can simplify. So negative 4 minus 2 would actually give us a negative 6, and then 4 minus 0 will give us a 4. All right, 2 things I have to check for. Can I simplify the signs, and can I simplify the numbers? So a negative over a positive is the same as saying a negative divided by a positive. It'll be a negative. So our sign can't be simplified here. So maybe we're already in our most simplified version, right? The sign is correct. So let's go to our checking our 6 fourths. So 6, my fraction button, ABC of my calculator we've been using, 4, enter button. Now, when I do that, it's going to give me a mixed number, but I'm not allowed to have decimals and I'm not allowed to have mixed numbers here. So I need to hit the second button on our class recommended TI-30X calculator and the ABC button again. And then the enter, because that's going to give me the improper version, but in its most basic simplified version. So when I hit equals here, if it brings me back up here to 6 fourths, then I know 6 fourths, the negative in this case, 6 fourths is already in its most basic version. If it gives me something different, which in this case it does, I need to go further and write the more simplified version, which is 3 over 2. Now, still with that negative sign. Now, I should have been able to tell that my answer is going to be negative based off this line to begin with, because if we were to start here and walk down, right, we'd be hiking down that mountain, right? We knew in the end that my slope had to be negative. So use the picture to help you. Think about your hiker, think about where we are, and make sure the sign on your answer matches the picture. Now, I'm saying use a slope triangle here to check your answer. And this is pretty cool. We can actually go in, now that since we have the picture here, I'm going to go ahead and erase some of this stuff out just so it's not confusing us too much, and create a slope triangle. So this -3/2 really says if I go down 3, right, the -3 means go down 3. And the +2 then means go to the right 2. So if I go down 3 and to the right 2, that should take me from one location on my line to another location on my line. That's what this -3/2 is, the change in up and down compared to the change left and right. So let's start up here and try to go to here. If I go down 3 to the right 2, do I go from 1 to the next? So 1, 2, 3 down, right? That's this guy. 1, 2, over, right? 3 down, 2 over. Yep, we're good. All right, let's try it again. Down, 1, 2, 3, over 1, 2. Triangle, 3, 2. Yep. So we're working, right? It's going to be that same pattern. If we go down 3 to the right 2, we should be back. That should get us to here, right? Down 3 over 2 will get us here. Down 3 over 2, right, will get us here, and so on. All right, so take a second and check your work. All right, number 2. Again, I've pre-put some points here to help us. So I only need 2. It doesn't matter which 2 I use. So I can use these 2 on the end. I can use the middle one with an end one, right? It doesn't matter which 2. I like using these intercept ones because I think they're easy to work with. But again, if you end up messing up these order pairs where you have a 0, comma, or something, comma, 0, then use one of your other ones where you're less likely to make a mistake. So up 1, 2, 3, 4 is our y-intercept. I'm going to use that one again. So 0, comma, 4. And then I'm going to use this one just because it has positive coordinates as opposed to this one, which has a negative. But again, this one over here is an x-intercept, so it would be fairly simple to use also because it would also have a 0. So 1, 2, 3, 4, 5, 6, 7 to the left, comma, 0 would work. Or in this case, to the right, 7, up 8, right, would be our other option. Pick any other point you want to use. I'm going to use the 7, comma, 8. But again, we could use that -7, comma, 0. All right, let's substitute in. M equals 8 minus 4 over 7 minus 0. All right, let's do our subtract, and then we'll think about whether or not it can be simplified. So 8 minus 4 would give us a 4. 7 minus 0 is a 7. All right, a positive divided by a positive is still going to be a positive. So we know the sign isn't going to simplify. 4, fraction button, ABC, 7, enter. If I get back, it's not going to give me a mixed number because this number is smaller than this one. So it's going to give me back the simplified version. If I get this guy back, I know I'm done. If I get something better back, then I need another step, right, where I write it better. In this case, positive 4/7 is our final best possible simplified answer, which means if I go up 4, then and to the right 7, I'll land back on my line. So let's check it. Up 1, 2, 3, 4. Right? 1, 2, 3, 4, 5, 6, 7. Up 4 over 7 gets me back to my line. This guy checks out. I should have known from the beginning that it was positive because if I start here at the beginning and I start hiking, we're going to head up the mountain, which means we'd have a positive slope. All right, let's look at one more from our graph version. All right, now I didn't put any points on here. I should already know in my head, right? This is a straight up and down vertical line. If I start here and I start hiking, plat, splat, boom, I'd be falling off the cliff. My answer should be undefined, which means my steps need to support that. The work I'm going to show needs to get me to having a 0 in the denominator because that's what causes an undefined slope. So let's look at it. I can put 2 points anywhere I want on this line. So I don't know, let's use this guy and like this guy, right? We can use any 2. So 1, 2, 3, 4, 5, 6, 7 to the right. And I went down 1, or 7 to the right and I went up 1, 2, 3, 4, 5. right? Those are the two I chose to use. Again, we could use any 2 points, right? I just didn't pre-pick them out here. So 7 comma -1 and 7 comma 5. All right, let's substitute in 5 minus -1 is what I picked there for our y's, and then 7 minus 7. Keeping in mind, I already know if I don't get 0 in the denominator, which leads me to the conclusion of undefined for my slopes here, I know I messed up with my ordered pair. So go back and relook at it. So 5 minus -1, would give us +6. 7 minus 7 is 0. All right, we're good. We have a 0 in the denominator, which gets us to our final slope here of undefined, which is good. So my work or my steps here support that picture of I would be falling off the cliff and we would have undefined slope. All right, last type is what if we're given a description of points on a line but in a table format? Now, the only thing that's a little bit different here, again, I have extra points, right? We have 1, 2, 3, 4 points here, right? Where we're told each of these creates an ordered pair of a location on a line. Right, so we have 10 comma 10 we could use. We have 2 comma -6, right? That's what that's showing us. 0 comma -10 is an option, and -5 comma -20, right? Those are all points. If we were to plot those four and take a ruler and connect, it would form a line. And we're being told that, right, by being told it's a line up here. All right, so we can pick any 2 out, right? We're going to have extras again, just like when we had the picture format. I'd pick 2 that I think are fairly simple, easy to work with. Like for me, 10 comma 10 and 0 comma -10 seem easy. So for me, 2 -6 and -5 -20 would be the ones I would probably throw out. All right, now, could I use any of the others? Yes. When I simplify in the end, it would give me the same exact final result. So our steps might not match perfectly in between, but when we do our simplifying part of the process, it should match up then. All right, so using the points I had picked out, we would have -10 minus 10 in the numerator and 0 minus 10 in the denominator. All right, -10 minus 10 actually gives us -20, and 0 minus 10 would just give us -10. All right, I got to run 2 checks. Can I simplify the signs and can I simplify the numbers? So negative divided by negative is a positive. So I know I'm going to have another step here that, and if nothing else, I'm going to have +20 over +10. I also have to check to see if I can simplify that fraction 20 over 10. All right, ABC button here to help you. When you do 20, ABC 10, ignore the negatives with your ABC button. We already know it's going to become a positive. So 20 ABC 10 would give us 2. But remember, we need a fraction. So that's really 2 over 1 when we write it in its simplified fraction version, which means this particular line, to go from one point to another point on our line, we'd go up 2 and to the right 1. All right, let's try another one like that. Number 11, what's the rate of change or the slope of the line described in the table? Again, remember, these create our ordered pairs, 24 comma 23, 12 comma 15, 0 comma 7, right? It's just in table format instead of ordered pair format. Again, I would stick to the ones that seem the easiest to work with. So for me, these bottom 2 are probably the easier ones to work with. And I would probably pitch or discard or ignore those top 2. But again, I can use any of them. So I'm going to use 0 comma 7 and -3 comma 5. Again, pick which ones you want to use. It doesn't matter which 2. As long as you do your math, your subtraction, and your simplify correctly, you should match up. All right, so 5 minus 7 would be in our numerator, right? These are our y's. And then -3 minus 0 would become our denominator. Subtract and see if we can simplify. So 5 minus 7 would give us a -2. -3 minus 0 is still a -3. All right, a negative divided by a negative is a positive. So I definitely have another step here. And if nothing else, that has to become +2 or +3. All right, run your second check. 2, ABC, 3, enter. It's going to give you back exactly 2/3 still, but make sure you give it back in its simplified version of +2/3. So if we were to graph these 4 points and connect them, we'd have an up the mountain line, and more specifically, an up the mountain line that goes up 2 to the right 3 before it gets back to a perfect location. All right, number 12, you try this one on your own. Try it. Pick out any 2 you want. If it were me, I'd probably use these guys. They seem the easiest to work with, and pitch those other 2. But again, you could use any 2 from the line. As long as it's told to me it's a line, I can use any 2 in that table. hopefully you picked out your points and did your math. I chose to use these guys here, so that's what I'm going to do. But again, you could have used others. So -7 minus -1. Right, this was I called this one my x1, y1. And I called this bottom one x2, comma y2. All right, that's what I assigned. But again, you could have done something different. All right, down here, then we'd have 5 minus 0. All right, so -7 minus -1 would become plus +1, which is -6. 5 minus 0 is just a 5. A negative divided by a positive is still negative, so the sign can't be simplified. And 6 ABC 5, mixed number, don't leave it that way. Second ABC gives me back 6/5 still, so this is already its most basic simplified version. All right, I hope that helps you attack your work for today. See you guys later.